number of rows is lesser than number of columns. That means here m is lesser than n, when m represent number of rows and represent number of columns. So here A is equal to Aij of order m by n, where m is lesser than n. That means if I take A is equal to, this is 2, 3, 4, 1, 2, 3. This is horizontal matrix because it is of order 2 by 3. Here the number of rows is lesser than number of columns. So any, it may be any. Okay, so here it is number of rows and number of columns, where m is lesser than n. Number of rows is lesser than number of columns. This is the point here. Horizontal matrix it is. Okay, any matrix of this kind, 2 by 3, 1 by 2. Okay, or I mean this maybe this is smaller, 2 by 4, 2 by 6, any number. It is horizontal matrix you have taken. Then what is vertical matrix? Second part, this is 15th part is 15th is or vertical matrix. Now what is vertical matrix? Vertical matrix. Vertical matrix. So a matrix in which number of rows is greater than number of columns in this case. Okay, so in which number of rows is greater than number of columns. This is the difference here. That is known as a matrix in which number of rows is greater than number of columns is known as vertical matrix. Known as a vertical matrix. Okay, and in this case is known as a vertical matrix. No, less than number of n is known as the row matrix here. Sorry, horizontal matrix. I'm sorry, I'm writing here vertical matrix, and this is horizontal matrix here. Horizontal matrix. So these two are defined here. Horizontal matrix is having more number of columns and number of rows is lesser. But in this case, number of columns is bigger than number of rows. Sorry, number of rows is more. We have written down is greater than number of columns. That means if I take, this is suppose 1, 2, 3, 4, 5, 6, etc. Now this is of order 3 by 2 here. 3 number of rows and columns are 2 here only. Maybe any, I mean suppose B is a matrix of order 1, 2, 3, 4. Okay, and this is 2, 3, 4, 5. This is of order 4 by 2. 4 rows and 2 columns. This is also column, sorry, this vertical matrix. Vertical, more vertically or more lengthier or more having heights and less width here. In this case, more width here and height is less. Columns are lesser. Columns are lesser here. Rows are more. Rows are lesser and columns are more. Okay, so in this case, this is forming horizontal form. This is the vertical form. Here height is greater. Here width is greater. In that case, in case of practical only, we can define in that way. So okay, this is how vertical matrix is defined. So vertical matrix is having more number of rows than columns. In this case, having lesser number of rows or columns are more than rows, number of rows. So this is how this matrix is there, vertical matrix. Now let us talk about the last type, which is known as submatrix. Now a submatrix is a part of a matrix a matrix obtained from a matrix from a submatrix is a matrix obtained from a given matrix. Okay, so if I take any matrix out of the given matrix, that is known submatrix. This is 16th submatrix. This is the submatrix here. What is submatrix here? So a matrix having obtained from a given matrix with lesser or equal order. In this case, some matrix is always having lesser number of order, okay, than the given matrix. It is a submatrix here. But a matrix is submatrix of itself. A matrix is a subset of itself. Similarly, every matrix is having, submatrices are also there. Some matrices are there. Some matrix is also a matrix is having a submatrix of itself or is a submatrix of itself. So submatrix is a matrix obtained from a given matrix with lesser or equal order. Okay, with equal order. That is, if A is equal to Aij, let me take here A is equal to, let me take 2, 3, 4, 5, 6, 7, 8, 2, 3. So this is a matrix of order 3 by 3. So another matrix, let me take B, is obtained from this matrix. This is 2 by 3, 2, 3 and 5, 6. This is order 2 by 2 undoubtedly. Only obtained from this is some matrix here. It is some matrix. Another matrix, if I take C, is a 2, 3, 4, 5, 6, 7. Is some matrix obtained from there. This is of order 2 by 3. 2 by 3, but elements are same. 2, 3, 4, 5, 6, 7. This is sum. These two are the sum matrices of this given matrix. Which is a sum matrix here. So sum matrix is a matrix obtained from a given matrix. A number of matrices are found here. We talk about this in detail, okay, in the next lecture series. Okay, so these are the some types of matrices. Now next I'll talk about what is adjoint of a matrix, inverse of a matrix, nilpotent matrix. Okay, then what is the Hermitian matrix? Okay, then what is the periodic matrix, etc. We will talk about this in detail in the next lecture series. Okay, so for today it is sufficient now. So type of matrices are taken here, definition, basic definition, or if I define what the application of matrix algebra, which I have already defined that. It is very useful for higher mathematics, for management students also it is useful for higher mathematics students, or in its application is found in higher mathematics like algebra, differential equations, aeronautics, okay, or aerodynamics, aerodynamics, astronomy, mechanics, or astrophysics also in which it is found, okay, and then differential equations. So all these subjects of mathematics, higher studies, they are finding matrix algebra as a part of it. It's very useful there. Okay, so for science students, for management students, it is useful. For management students, for example, managers, they can take decisions very easily after solving the simultaneous equations with the help of matrix algebra. This is the usefulness of for management students. Okay, so for management students, we always talk about that how matrix algebra is useful for managers. Okay, so taking decisions, it is very useful. Okay, so now I'll take the other topics, the addition, subtraction, multiplication of matrices, what are the rules of matrix algebra, multiplication or matrix algebra. That we will talk about in the next lecture series. Okay, see you in the next lecture series. Bye bye.